This is water boiling at room temperature using a vacuum pump and vacuum chamber. In this video, we're going to explore why and how pressure affects a liquid's boiling point. Let's start with some basics. Atmospheric pressure at sea level is 14.7 psi. A vacuum is the removal of atmospheric pressure. Anything below 14.7 psia would be considered a vacuum. Now let's go over what actually has to happen in order for boiling to occur. All liquids have a vapor pressure. If the pressure exerted on the liquid is stronger than the liquid's vapor pressure, the liquid will not be able to boil and escape in vapor form. On the other hand, if the liquid's vapor pressure becomes equal to or stronger than the atmospheric pressure exerted on it, boiling will occur. Typically, we bring liquid to a boil by adding heat. As the temperature rises, the liquid's vapor pressure rises. For example, we know that at sea level, atmospheric pressure is 14.7 psia, and water will boil at 212 degrees Fahrenheit. Water's vapor pressure at 70 degrees Fahrenheit is 0.36 psia. As we add heat, the vapor pressure increases. What do you think the vapor pressure of the water is when it reaches 212 degrees and starts to boil? Yep, 14.7. When we add heat, the water's vapor pressure increases. Once the liquid's vapor pressure reaches the same as the pressure exerted on it, the liquid's vapor pressure is able to overcome and escape in vapor form. So adding heat is one way to make a liquid's vapor pressure be able to overcome the pressure exerted on it. But there's another way. If we remove the pressure exerted on water, it makes it easier for the water's vapor pressure to overcome the pressure exerted on it. For example, at 150 degrees Fahrenheit, water's vapor pressure is slightly greater than 4.5 psia. If we use a vacuum pump to decrease the pressure exerted from 14.7 down to 4.5 psia, water's vapor pressure is able to overcome the pressure exerted on it, and we're able to boil at 150 degrees instead of 212 degrees. On the flip side of this, if we increase the pressure exerted on the water, it would make it harder to boil. For example, if we increase the pressure exerted on water from 14.7 psia to 20 psia, it wouldn't be able to boil at 212 degrees. This is because water's vapor pressure is only 14.7 psia at 212 degrees. In order to boil, we'd have to heat the water to approximately 259 degrees Fahrenheit. This is because at 259 degrees, water's vapor pressure would become 20 psia and able to overcome the pressure exerted on it.